we are graphing both exponential and log functions today, okay? We're going to start out with some parent functions of 2 to the x and 1/2 to the x, and then we'll do some transformations to that as well, okay? You guys have probably seen these graphs before. I showed them to you last class when we were doing that warm-up or that little like whiteboard activity. We had exponential growth, exponential decay. Hopefully those words sound familiar. You guys have seen that before. So we're going to pick some x values and we're going to plot some things, and let's talk about it. So with my x's and my y's, normally when you pick x's, when you plug them in, a lot of the times you've done like -2, -1, 0, 1, and 2. Yeah? We'll just kind of keep that pattern going. I think that's a good idea. I really want at least 3 points, okay? So anything extra is just good, okay? So when I'm plugging these values in, my base is 2, I'm raising it to the exponent of x. Let's start with my positive numbers because those will be easier to plug in. 2 to the 0 power, what's that give me? 1. 2 to the 1 power is 2, and 2 squared is 4. Now if I go the other way, I'm going to make some fractions, right? 2 to the negative first power is 1 over 2, right? Or 0.5. And what would 2 to the negative second power be? 1/4 or 0.25. Okay? Question for you. Can I plug in a value for x into this function and ever get a negative y value? No. Okay, so what does that mean that we're going to have at y equals 0? A horizontal asymptote. So I need to go ahead and draw on here a horizontal asymptote at y equals 0. And then I can just plot the rest of my points. -2.25. And there we go. So we're growing pretty rapidly on the right-hand side, but we are getting really, really close to that horizontal asymptote there at 0, okay, or the x-axis. Now, if this number was not a 2 and it was like a 3 or a 4 or a 5, what do you think is going to happen to that graph right there? Yeah, it's going to go up more rapidly, quicker, right? So over here, it's going to get closer and closer to that y-axis, okay? So make sure you're looking at what the base is when you're graphing these ones. Okay, well then I've got letter B here, or y equals 1/2 to the x. Is this the same as, could I write this as 2 to the negative 1x power? Yes. Yeah, because this would be 2 to the negative 1 and then times that x. So this is the same thing as 2 to the negative x power, right? So if I were graphing or plotting my points of x and y, I decided today that I'm going to start writing my y's like that because I just think they look pretty. Fun fact. Okay, I'm going to plug in the same values. Say -2, -1, 0, 1, and 2. Okay? Now, let's think about what is this negative doing up here with that x? What does it do to my graph? If we think this is my parent function over here, what's that negative x do? It flips it, right? What does it flip it? Does it flip it across the y or does it flip it across the x? It flips it across the y value. If there was a negative in front of this 2, then it would flip it across the y value, okay? Or the y-axis, I mean. So all of these values are just being reflected across the y-axis, okay? So we can either do one of two things. We can plug those values in, -2, plug it in, -1, plug it in, or we've already gotten the values for x and y over here. We just need to reflect them over the y-axis, yeah? So like this point at 0, 1 is going to stay at 0, 1 because it's on the x-axis, right? So I'd plot that point. What about at the point 1? At 1, we were at 2. So if I want to flip it over the x-axis, isn't it still at? For -1. At -1, it would be also at 2, right? And then if I look at +2, we are at 4. So if I'm looking at -2 and I flip it over, at -2, I would also be at 4. Okay, so do we see how this pattern over here is just being flipped? Oh wait, it should be +4 though, not -4. Okay, your pattern is just getting flipped. So I've got 4, 2, 1, and then 0.5. Oh, that's way too large. 0.5 and 0.25. Again, we can also plug in the values and get our outputs as well. So let's go ahead and plot these points. And my horizontal asymptote is still at the line y equals 0 because it was not shifted up or down at all. So I can go ahead and sketch my graph. Okay, so this is what we call an exponential decay kind of graph, what it looks like. And then the one on the left is a growth. Right, it's growing quickly, and letter B is getting smaller and smaller or decaying. All right. Okay, this next example here, we've got some transformations that are happening to my parent function of 2 to the x. Okay. This first one, I've got a negative in front. This negative in front of our function of 2 to the x does what? Reflects it, right? But reflects it over the x-axis. Okay, so if I make my table here of x and y values, I'm plugging in -2, -1, 0, 1, and 2. And then again, instead of having to actually plug in those values, let's think about our parent function here above. We're taking all of those values and we're flipping it over the x-axis. So what's that going to do to all of my y values? Make them negative, right? So it's going to be the same y values, but I'm going to make all of them negative. So this is -0.25, -0.5, -1, -2, and -4. So I can go ahead and plot these points. And I still need to draw my asymptote in there. Did it shift up or down at all? No, so I'm going to still have my horizontal asymptote at y equals 0. Feeling okay so far? Cool. All right, next one, letter B. I've got f of x equals 2 to the x plus 3. So if I've got something happening with my x, what type of transformation is happening there? It is moving, yes, left 3, shifted left 3 units. But my y values are not changing. The entire function is just shifted left 3, right? So if I think about my table of x's and y's, I've got my -2, -1, 0, 1, and 2, and my y values aren't changing. However, I need to shift all of my x's left 3. So really, these should all be what? Subtract 3 from those, right? So I can subtract 3. I get -5, -4, -3, -2, and -1. Do you guys see what I did there? Just changing those values. Or you could plug in, obviously, the -2, -1, 0, 1, and 2. But again, it'll just take you a little bit longer. Either way, though, is fine, as long as you have at least 3 points on your graph. Okay? So I'm going to plot these points. -5, -4. And my horizontal asymptote has not shifted at all, so we are still hanging out at 0. And I did it again. We actually needed to do 2 more things for this example. We need to determine what the domain and range are for these functions. Okay, so real quick, with the person sitting next to you. Double check your answers with them. Identify the domain and range for each of these functions. All right, do we all agree with those answers up there?
Yeah.
Domain are all real numbers for both of them, and then the range is the opposite for each of them, okay? Cool. All right, and the last one here. I've got 2 to the x plus 3 on the outside, so what does that plus 3 do? If it's not with the x, it shifts where? Up 3. Shifts up 3. So if I think about that in terms of my table, right? All of my x values are going to stay the same. My y values, however, what are we going to do with them? Plus 3 to all of them, right? So we could write out our table. All of my x's stay the same. My y values, I'm taking all of these values here and I am adding 3 to them. Or you can actually plug them in each individually and actually evaluate them, okay? But this is what I would do. All right, now where does my asymptote move to? 3, right? I've got to shift it up 3. So at y equals 3. And here is my graph. Okay, go ahead, write your domain and range for this graph. All right, we should have gotten all real numbers again for my domain, but my range is 3 to infinity. Make sure we are not including those values at the asymptotes. Okay, so 3 and 0 we're not including, okay? All right, you guys have seen compound interest before, yes? So these should be nice, kind of a refresher. All you're doing is you basically just plug in and chug in these numbers, okay? So you've got your compound interest formula. You will have to have these memorized, so don't forget them. If we are compounding them not continuously, but for a certain amount of times per year, we're going to use this formula. So what is my principal? If I look at example 1, how much money am I plugging into the bank? 1,000. It says an annual rate of 4%. Sometimes I see people do this. 0.4 is wrong. That's 40%. That'd be really cool. However, your rate is actually just 0.04. Your N stands for number of times per year. So it says compounded quarterly, which means we are 4 times per year. If it was annually, how many would it be? 1. If it was semi-annually, it would be 2. Okay, good. And then my T is my time in years, so 10. Okay. Now, I want us to plug all of this into the calculator at the same time. So you're plugging in 1,000 times 1 plus 0.04 divided by 4 raised to the power of 4 times 10 or 40. Okay? So everyone try plugging this into the calculator right now. Remember, if you wanted to make a fraction, you hit alpha y equals, right? And if you need your exponent, to get your exponents, use the little caret button. So try that out. We should all be getting 1,488.86, okay? Okay, this one now, this example, we are compounding continuously, so you've got a different formula to use. And remember, compounding continuously means you're using your PERT formula. E is actually a number, right? Anyone know what the number is? 2.7 something, yeah? Good job. So I've got a total of putting $5,000 being deposited in the bank, paying 3% compounded continuously for 5 years. Find the total amount at 5 years. So our principal is 5,000. Our rate is what? As a decimal, we got a 0.03. And our T is our time, so 5 years. And we plug this in to our formula. Oops, I don't know why I put a negative there. And double check yourself. You should get, hold on, number, 5,809.17. Plug that in. Make sure you all know where the E button is on your calculator so you can evaluate those. Okay, before we actually graph these logarithms, let's go talk about domain really quick. So let's look at example 2 here. Okay, if I want to find the domain of a logarithmic function, okay, if we thought about rewriting, if we had y equals log of 2, of x, right? I would rewrite this as 2 to the y power is equal to x. Do you guys agree? Okay. If this was 0, what I'm trying to say is actually, can 2 to the power of anything equal 0? It could equal 1 if it was raised to the 0 power. But can I ever get 0? No. Okay, in all of the graphs that we've done so far, right, everything, unless it was flipped over the x-axis, right, everything is positive, right, for my y values. Yes?
Yeah.
So when I'm talking about logs, we're reflecting everything over that line of y equals x, okay? So your normal log function looks like this. I'm going to reflect it over this line, so it's going to look something like that, okay? So our domain for a normal function, if it's just log based something of x, is going to be from 0 to infinity instead of negative infinity to positive infinity, right? We talked about when we switch our x's and y's and find our inverses of each other, our domain and range also switch, right? So our domain of this function was all real numbers, right? But my range of this function, my range was 0 to infinity, right? So now that we're talking about logs, my range is from 0 to infinity unless things have been shifted, okay? So kind of make yourself a little note here. You have to have everything greater than 0 in the argument. What I mean by that is the stuff in the parentheses next to my base, okay? So that is my argument, is what I'm calling that. My argument must be greater than 0. Okay? So these first two are pretty straightforward and easy. We're just looking at that stuff right next to my base. So I've got x minus 1 is greater than 0. Solve that, we get x greater than 1. Yes? If I was to write that as an interval, my domain would be from 1 to positive infinity. Okay. Letter B, I have log base 3 of x, and then I have a minus 1. Okay? I am not doing x minus 1 in parentheses, I'm not doing x minus 1 greater than 0 because it's not in parentheses. I am just looking at the thing right next to the base of 3. So I'm just setting x greater than 0. Well, if I wrote that as an interval, it would be from 0 to infinity. That is my domain. And then letter C and D have a little bit more things going on here. If I look at the absolute value of x, that's the thing that's right next to my base, right? That means the absolute value of x has to be greater than 0. Is this just from 0 to infinity that makes this true? No. Couldn't I plug in any negative number here and also get a positive?
Yeah.
So what is the only number that I cannot plug in? 0, right? So technically, if you remember back to your Algebra 1, Algebra 2 days, right, when you have an absolute value, you split this into two equations of x greater than 0 and x less than 0, right? And if I were to write my domain for that, exactly what you guys said, everything except for 0. So negative infinity to 0 and from 0 to infinity. Okay, if this was like if it was like absolute value of x plus 5, right? If you had absolute value of x plus 5, the only value that this cannot be would be what? 5, right? You would solve these two inequalities, and you would see x is greater than 5, or sorry, negative 5 and less than negative 5. Greater than and less than negative 5. So negative 5 can't be our answer, right? Yeah? So it'd be from negative infinity to negative 5 and negative 5 to infinity. So, very good. And then letter D, what kind of function is x squared minus 4? A quadratic, right? So it is not a linear term, so it's not just going to be one number that we're going to find here. When I set x squared minus 4 greater than 0, what can I do with that? Yeah, I can factor it, right? So this now becomes x plus 2 and x minus 2, right? Now, what does that mean in terms of my domain? Well, I know that negative 2 and 2 cannot be in my domain, right, because it would make that 0. So we need to think about a number line, because which numbers make it true? Negative 2 and 2. And then we are testing a point back into this inequality right here. If I plug in 0, I get 0 squared minus 4. Is that greater than 0? Is negative 4 greater than 0? Nope, so this interval is false. Okay, if I plug in 3, I get 3 squared, which is 9. Is 9 minus 4 bigger than 0? Yes, this is true. And then the same thing would be for negative 3. If I plug in negative 3, I also get 9 minus 4, right? So that is also true. So my interval for the domain for this function is from negative infinity to negative 2, and from 2 to positive infinity. Okay? Domain. And these would be open circles, right? Because if I plug that in, it would make that inequality 0, and it cannot have that equal to 0. Okay? Questions about domain? All right, then we got to graph some log functions here, okay? When we are graphing and figuring out what the domain and range are of these functions, we need to change this into an exponential, okay? Because I don't know what log base 2 of a number is in my head, right? So we need to change this. Let's pretend this is a y instead, okay? This now becomes 2 to the y power is equal to what? Is equal to x. So 2 to the y is equal to x. All we're doing from our original function of 2 to the x equals y, which is what we started with, we're just switching those x's and y's. This is the inverse of an exponential function with the base of 2, right? Okay? So if I plug in some values of x and y, we're going to plug in values for y this time, okay? Because if I plugged in values for x, again, are we going to be able to solve those very easily? No. So our numbers are going to go in for y, negative 2, negative 1, 0, 1, and 2. And then when I plug those in, if I put, I'm going to start with 0, 1, and 2 because those are the easiest. 2 to the 0, that would give me 1. 2 to the first would give me 2. And 2 squared would give me 4. This is the exact same pattern as before. However, instead of having these values in the y's, we have them in the x's, right? So at negative 1, what's my value going to be? 0.5, and my negative 2 would be 0.25, okay? So now let's plot these points and see what it looks like. So my x value is 0.25, negative 2, negative 1, and 2. Okay. If you think of this terribly not straight line there, pretending that's at y equals x, right? This is exactly the inverse of our function. This is, bless you, 2 to the x is equal to y, and this is 2 to the y equals x. You guys see how those are basically the same thing, just reflected? Okay, a question on your homework is going to ask you, if you're given like the function, tell me what the inverse function should look like if you're given the actual graph. So if I know that there's a point on my graph for my function of 0, 1, we know that that point is going to be 1, 0 on our inverse function, right? Okay, because it just switches the x's and the y's. Okay? All right, and then the next one, letter B, we have, oh, I forgot one thing before that. Where's my asymptote at this time? It's not at x equals, or sorry, it's not at y equals 0. It's at x equals 0. I talked too fast there. Gave it away. Okay, so it's at x equals 0. What is my domain and my range? Domain would be from 0 to infinity. And my range is negative infinity to positive infinity. Okay? Also, a little flashback from previous unit. Is this function here increasing or decreasing? Increasing. Very good. All right, letter B, let's pretend this is just a y instead of g to the x, or g of x. And I need to rewrite this, okay, as an exponential. So my base is 1/2. I'm raising that to the power of y, and that equals x. Okay, so when we're graphing logarithms, we are actually plugging in values for y, not for x. So in my xy chart, I'm plugging in the -2, -1, 0, 1, and 2 for y, not x. Yeah. Okay, this is also the same thing as, don't you agree? 2 to the -1 y is equal to x. Yeah? Okay, so let's plug these values in. If I plug in 0, we'll start with 0, I get 2 to the 0, which is 1. If I plug in 1, I get 2 to the -1 power. So 2 to the negative first power would give me 0.5. And 2 to the negative second would give me 0.25. Plugging in -1 here, -1 times -1 is 1. So I get 2 to the first power. And then I also get 2 to the second power, which would give me 4. Again, these are the same numbers, are they not? However, again, just in a different order, okay? Because there is a transformation that is happening here technically from that graph that we just did, okay? All right, let's graph these on our graph here. 4, -2. And I'm still going to have my my vertical asymptote there at x equals 0. Okay, so if I look between these two graphs here, if I look between these two graphs, do we see how this is increasing, right? This function is decreasing. Isn't this graph and this graph, aren't they just a reflection of each other? But a reflection over what? The x, right? This -1 here, that's with my variable, is reflecting it over the x-axis. Okay? Cool. All right, those are my parent functions for log base 2 and log base 1/2. Now let's go look at some that have some transformations happening on the second page. We got 3 examples left and then we're done. Okay, starting out with letter A. Go ahead really quick for me. Rewrite this in terms of an exponential. Rewrite this in terms of an exponential and have it equal x. Okay, if I rewrite this here, I'd have 2 to the y power is equal to x minus 1, which really is the same thing as 2 to the y power plus 1 is equal to x, yes? Okay, so this is the function that we are graphing, okay? When we are talking about logs, though, and talking about transformations, I want you to use the original log function to describe what's happening, okay? This -1 does what? Shifts it right 1, okay? Do you see how if I look at this function here, it doesn't necessarily look like it's being shifted right 1. It looks like this +1 means I'm going to move it up 1, right? But that's because we've changed our x's and our y's. So our transformations don't mean the same thing after we flip them, okay? So always kind of figure out what your transformation of your function for your log is going to be from your original function and then change it over to actually graph it, okay? So I know we're being shifted to the right 1, so my vertical asymptote is going to be at x equals 1, right? So vertical asymptote here at x equals 1. Okay, we're also figuring out what our asymptotes are and what our domain and range are for these problems, so don't let me forget those. Okay, then from here we can just plug in some x and y values. X and y, again, since my exponent is a y, I'm going to plug in y values. So I'm going to plug in these -2, -1, 0, 1, and 2 for y and figure out what is my output going to be for x. Okay, go ahead real quick, people around you, figure out what is your x value is going to be for those 5 if you plug them in. All right, I'm going to write them up here. We should have 1.25, 1.5, 2, 3, 5. You guys all get those? Okay, and I plot these. And then we need to identify what is my domain, what is my range, and what is my x-intercept. And when we write our x-intercept, we have to write that as a what? As a coordinate, right? Or as an ordered pair. So I need an x and a y. I don't need x equals 3 as my answer or x equals 2, right? So what is my domain going to be? 1 to positive infinity. My range, -infinity to infinity, and my x-intercept would be at 2, 0. Okay, we can figure out my domain both by looking at our graph and also, remember, by looking here at our argument, right? X minus 1, if I set that greater than 0, you get from 1 to infinity still for your domain, yes? If you're looking at a graph versus if you were just looking at it by hand, you could tell me what that is, yeah? Cool. All right, look at letter B here. Letter B, I've got y equals log base 3 of x minus 1. This minus 1 is not part of that argument. So before we change this into an exponential, what does this minus 1 do? It shifts it down 1. Okay? Shifts that whole thing down 1. All of my y values are just being subtracted by 1 there. And all of my x values are staying the same, right? Except for this time I have a log base 3. It's not log base 2. Okay, so we don't know what these numbers are. We've actually got to figure them out. So before we figure out what they are, though, we need to rewrite this as an exponential. So this becomes 3 to the, oh, actually, I need to do something first. What do I need to do? Move the 1 over, okay? Before I can actually do the change into exponential, it has to be just the log on one side. So this becomes y plus 1 is equal to log base 3 of x. And now I can go ahead and rewrite this as 3 to the power of y plus 1 is equal to log, nope, not actually. It is equal to what? 2x. Okay? So this is now my function that I'm going to plug in values for. If I have my x and my y chart, I am plugging in values for which, x or y? Y, so that I can actually evaluate them. Okay, if we start with 0, those are easier. So 0 plus 1, that's 3, so I get 3, right? If I plug in 1, 1 plus 1, 2, so I get 9. And if I plug in 2, what do I get? 27. So that's actually not going to be on our graph, but that's okay. We've got a few other points that are. If I plug in -1 plus 1, that's going to give me 0, which is 3 to the 0 power, which is 1. And if I plug in -2, I get 3 to the -1st, which is just 1/3. Okay? So if I plot these points, I didn't shift this over at all. Did I do something wrong? Did I? No? You sure?
You just changed the way you're writing. Like the x. You wrote it as 1/3 and not point.
Oh, 0.3. Let's change that then.
No. The fractions are better.
Either one's fine. Yeah.
Oh,
Now it's wrong. 9-1. Okay, did my vertical asymptote shift at all? Nope, so it stays the exact same at x equals 0. Okay, so go ahead, take a minute, find your domain, find your range, and label your x-intercept. What are those 3 things? Did we all get these 3 things up there? Good stuff. Whoa. Okay. And last problem here. Got a few more things going on. There's actually 3 transformations. Tell the person sitting next to you what those 3 things are. So now before I can actually graph this, I do need to change it into an exponential. Yeah? So I got to get rid of that -8. I'm going to actually write this down here because I feel like there's not enough space. So I'm going to rewrite this as -4. Okay. That was a funky 8. What am I going to do first? I got to add the 8 over, right? So this becomes y plus 8 on the left side. And now I've also got to get rid of my -4. So I'm going to divide by -4. And can I change this into an exponential now? Yes. So this now becomes 2 to this exponent. Ugh, gross. Is equal to just x. Okay. So we got to plug in some values. Okay. Before we plug in values, let's think about this for a second. Has my graph been shifted left or right at all? It has not been. So my vertical asymptote is still at x equals 0, correct? Okay. So I got my function. Now I need to plug in some values of x and y. It's going to be a little gross. Could we maybe pick some better points to plug in? Instead of like -2, -1, 0, 1, and 2? If I plugged in 0 for y, if I plug in 0, I would get 2 to the 8 divided by -4, right? What is 8 divided by -4? -2, so 2 squared would be, 2 to the -2nd, right? Would be 1 over 4 or 0.25, right? Okay. What if I plugged in, what's another maybe good number we could plug in for y? 4 and -4? I like it. Let's plug in 4. If I plug in 4, I get 12 on top, divided by -4. So that would give me 2 to the -3rd, which would be 1 over 8, which is 0.125, I believe. Let's plug in -4. If I plug in -4, I get 2 to the 4 divided by -4, right? 2 to the -1, or 0.5. So we see a pattern. We're getting bigger as we go more negative there for my y's. That kind of made sense. That was kind of backwards there. But let's pick another negative number, a smaller negative number than -4, so we can get a bigger x value. Maybe like, what? -12? Let's plug in -12. If I plug in -12, it's yeah, you're right. A smaller number than -4. My bad. So if I plug in -12, I get 2 to the -4 over -4. That one equals 2. Yeah? So if things like this happen, I would maybe not plug in your -2, -1, 0, 1, and 2. I would think maybe a little bit more critically about what could I plug in that would be a little easier. Yeah?
You can though, right?
What?
You can plug in those.
You can plug in those numbers, yes, but you're just going to get really, really small numbers, and it's going to be kind of hard to evaluate. Yeah. Okay, so on my graph, I'm going to plot these points here. 2 is all the way down off the graph, actually. Yeah. Oofta. There we go. Super stretched out there. Okay? Is that what your graph looks like? Good stuff. So now we need to identify what is my domain, what is my range, and what is my x-intercept. What's my domain going to be? Domain. Domain starts at 0 and goes to infinity. My range is all the way from negative infinity to infinity. And what is my x-intercept? We found that, didn't we?
140.
Yeah, 140 or 0.250. Okay, if we didn't find it evaluating it on our table, we could also set this equal to 0, right, and solve it. Back up here, I mean. Our y value equal to 0, and we could actually solve that and get our x value, okay? All right. How do I feel about graphing logs and exponentials? Pretty okay? Yep. All right. If you got questions, please ask, but let's